Don't look at me. Okay. So 6.3 is kind of taking the stuff that we've seen with matrices and putting it together with word problems, more specifically economics. So basically what we're going to look at is if you have goods, you are using goods, you're producing goods, how many or how much of a good do you need to produce in order to make a certain amount of that good. Okay, so example 1 kind of deals with just one unit of this. So we have a single good of lumber. And in a general case, when we produce a good, some of it is going to be consumed. Okay, so we lose some of that good. Reason being is that we need to make more of that so that when we lose part of it, we actually make what we're supposed to be making. So suppose 0.2 units of lumber is consumed in the production of 1 unit of lumber. And then suppose we have an order for 10 units. We need to figure out how many we need to produce in order to make the 10. So I'm going to set X equal to the number of units of lumber. And when I make 1 unit, okay, so 1X, we are losing, okay, or consumed, that's what that means. We are losing 0.2 of a unit. Okay, so by making that 1 unit, we're actually also losing 0.2 of a unit. We need that to add up or to equal our total order of 10 units. Solving for X, we get 0.8X equals 10. Divide by 0.8 or 8/10, and we get 12.5. So in order to make the 10 units of lumber, we actually need to make 12.5 units so that when the 0.2 is consumed, we get the correct amount. So 12.5 units of lumber. Now we are going to do this with more than one good, and that's where the matrices will come into play. So kind of paragraph down at the bottom. If we have 2 goods, okay, we'll look at, it'll say in 1 unit of creating lumber, we need lumber and steel. I know that sounds funny, but that's how it's going to look. And then in 1 unit of steel, we need this much of lumber and this much of steel. So that's how we're going to kind of get our matrices to set up. We have 3 different types of matrices. We're going to have an A matrix, an X matrix, and a D matrix. This information down here is important. Okay, we've kind of already seen that X equals A times X plus D. Matrix A is going to be your technology matrix. So that's going to tell you how much of each good you are using to produce another good. Matrix X is your production schedule. So how much of each of those goods do you need to make? And then matrix D is your demand vector. So what is your order looking like? So the 10 from example 1 would be a part of matrix D. The 12.5 from matrix, from example 1 would be matrix X. Good morning. I'm great. Thanks. See you, friends. See you, friends. Okay. See you later. So the 12.5 comes from the production schedule. We need to produce 12.5 units of the lumber in order to make that demand. And then with the technology matrix, that would be the 1 and the 0.2. Okay, this equation right here is going to be important so that we know what to set equal and how to solve for this. Example 2, we're dealing with 2 units here. The other name that we call this is the Leon-T input-output model. So that's fancy name for it. I just refer to it as an economic model. So we have two goods here, steel and coal. I'm going to label good 1 as steel and good 2 as coal. Okay, it gives us information that 0.1 unit of steel and 2 units of coal are required to produce 1 unit of steel, and 0.3 units of steel is required to produce 1 unit of coal. We are just looking for the technology matrix. Okay, so that's going to be, since we've got 2 goods, we'll have a 2 by 2 matrix. Now, when I set this up, I had good 1 was steel and good 2 was coal. Okay, so my first row is going to represent steel. My first column is going to represent steel. Second row and second column will represent coal. When we look at these, we're going to go through columns. Okay, so I'm going to start here with steel. Okay, first sentence says 0.1 unit of steel and 2 units of coal are required to produce 1 unit of steel. So we're producing 1 unit of steel in column 1. I need 0.1 units of steel to produce that, and I need 2 units of coal. So you can see where steel and steel line up. That's how much steel we're using to produce steel. Where steel and coal line up, that's how many units of coal we are producing for steel. Okay, we go through and set them up as our columns. Okay, so be careful that we're doing them in columns rather than our rows. For the 1 unit of coal, it says all we are using is 0.3 units of steel. So for coal and steel, I have 0.3 units. It said nothing about using up coal. So if there's something that is missing a term, we'll just put a placeholder of 0. Okay, that's it for setting up that technology matrix. That's all you have to do. One of the things that we will go through and solve for a lot is that production schedule, okay, which is essentially what we did in example 1. We just did it in terms of 1 good rather than 2 or 3. This equation okay, comes from that x equals a times x plus d. So if we are ever asked, and this will be a common thing, to find that production schedule, okay, I, what does that stand for? Identity. My identity matrix. What does my identity matrix look like? My ones, my leading ones, and everything else is zeros. So we're going to take the identity matrix minus whatever your technology matrix was. So we've seen that, subtraction. We're going to take the inverse of that, we've seen that, and then we're going to multiply it by the demand vector, okay? You will be given, or should be given, the demand vector. The technology matrix is something that you can find, and then the identity matrix is just something that we know, okay? So you'll have some way to find each of those in order to use them. So example 3, we're using the technology matrix that we set up in number 2. It says, recall the first row and column is identified with steel, second row and second column is with coal. So suppose the external vector is 12, 3. That means D is equal to 12, 3. So we want to produce, or there is a demand for 12 units of steel and 3 units of coal. Okay, but because things are used up, we actually have to make a little bit more than that in order to fulfill those orders. So it says find the production schedule which meets the demand. So production schedule is going to be X. Okay, they're not always going to tell you solve for X or solve for A or solve for D. They're going to use find the technology matrix, find the production schedule, or the demand vector. So you're going to need to make sure that you know which ones stand for which. So I've got this equation of X equals I minus A inverse times D. So they gave us D. We figured out A in example 2. So first thing I'm going to find is I minus A. And you're going to see me kind of skip over some stuff just because Things like finding the inverse and subtracting and multiplying are things that we've seen before. So I minus A, keep in mind that I, for a 2 by 2, is this guy. So I'm looking at 1, where am I? Minus 0.1 to get me 0.9. 0 minus 0.3 to get me negative 0.3. 0 minus 2 to get me negative 2. And then 1 minus 0 to get me 1. And make sure that you are doing I minus A rather than A minus I, because they will get you 2 different values. All right, if you go through and take the inverse of that, okay, so put it along with that identity matrix, go through all of your row reduction, we should end up with 10/3 and 1 for our first row, and 20/3 and 3 for our second. Last thing we have to do is multiply this matrix times our external vector. So when we do that, we would have, let me label this, 1 minus A inverse times D. Okay, I'm doing a 2 by 2 matrix times a 2 by 1 matrix, so I'm allowed to do that. I should end up with a 2 by 1 matrix. And when we simplify this, we get 43 and 89. Okay, this right here tells us, so that first row represented steel. So in order to make that demand of 12 units of steel, we actually have to produce 43 units of steel. In order to make the demand of 3 units of coal, we have to produce 89. Okay. So a lot of the same stuff in terms of the subtraction, the inverses, and the multiplication, but or just in terms of goods. All right, next page. I'm not really going to go through that. Basically, what that says is we can do this for any amount of goods. Okay, it works for 2 goods, 3 goods, 100 goods. So essentially, we end up with the same thing, the same technology matrix, your production schedule, the demand vector, same equation that we saw. So that's something that will pop up a little bit or a lot of it from here on out. So example 4 says, suppose we have 3 goods, okay, cement, electricity, and steel, and a technology matrix in which they gave us. Something to keep in mind, cement, electricity, and steel. I don't think it asks us specifics, but we want to make sure that we're in that same order. It's asking us to find the external demand, which will be met by the production schedule. So we kind of have 2 different equations for these that we look at. So that x equals A times x plus D, and then the x equals your identity matrix minus A inverse times D. Our goal here is they want us to find the external demand. Out of these 2 equations, this one's probably going to be easier to solve for D. Okay, here we can't go through and divide both sides by that identity minus A raised to the inverse. So I'm going to use this guy. And first thing I'm going to do is solve that for D. Okay, so I just take that A times x. I can move that entire thing over by subtraction. And we know what x is equal to, and we know what A is equal to. So that left-hand side of that equation, I can set up as 30, 20, 40, minus matrix A, so 0.2, 0.6, 0.2, 0.1, 0.4, and 0.6, 0.3 times that 30, 20, 40. Okay, so what those equations will really do is allow you to determine what you're adding, what you're multiplying, subtracting, what you're finding the inverse for that kind of stuff. All right, if you multiply, oops, this is 20. Multiply A times X, we get 26, 18, and 30. And subtract those. So we would get 4, 2, and 10. And that is matrix D. Yes, sorry. Thank you. Okay, so what that means kind of in general is that we need to make 30 units of cement, 20 units of electricity, 40 units of steel in order to meet the demands of the 4 units of cement, 2 units of electricity, and 10 units of steel. Alrighty, example 5. And this one I believe is similar to, which is that one, 3, except we have 3 goods instead of 2. So we've got an economy which produces 3 goods: hydroelectric power, propane, and titanium. So this is going to be good number 1, good number 2, and good number 3. I would say technically the order does not matter as long as you are consistent. So if you make row 1 propane, row 2 hydroelectric power, that just means when you're looking at your production schedule or your demand vector, those 2 would have to be flip-flopped. So you would just have to make sure that you correspond with whatever rows you set up. It gives us, let's see, I'm going to go ahead. I'm going to set up my technology matrix because they don't give that to me. And it asks to find that first. So we're finding 2 things. So for the technology matrix, okay, since good 1 was hydroelectric power, propane, and then titanium. You don't have to write those on the outsides of your rows and your columns, but you can, at least for the time being, to kind of help you organize where things are going. Okay, so 1 unit of hydroelectric power, we're filling the column for hydroelectric power, requires 0.5 units of hydroelectric power, so that's going to be 0.5 in that top spot. 0.2 units of propane, and 1 unit of titanium. Production of 1 unit of propane, so now we're in column 2, requires 0.8 units of propane, so that's where those guys meet, and then 0.4 units of titanium. It requires no hydroelectric power, so we're putting a 0 there. And then production of 1 unit of titanium requires 0.2 units of hydroelectric power and 0.12 units of propane. So it requires 0 units of titanium. Okay, we're finding the technology matrix, which we just did, and find a production schedule. Production schedule is matrix X. Okay, so out of my 2 equations, I'll go back up here so we can see them. Out of these 2, this one's probably going to be the easier one to solve for X for. Okay, X is already by itself. We know what the identity matrix is. We just figured out what A is equal to. Let me write this down here so you've got it. The only thing that we need is the demand vector. Okay, but if you look at that last part, it says which will satisfy an external demand for 5 units of hydroelectric power, 3 of propane, and 4 units of titanium. So D is going to be equal to 5, 3, and 4. Okay, so we do have the identity matrix, our technology matrix, and our demand vector. So first thing I need to find is identity minus A. which ends up being 0.5, 0, negative 0.2, negative 0.2, 0.2, negative 0.12, negative 1, negative 0.4, and positive 1. Inverse, okay, so we'd set that up with our identity matrix, go through row reduction, ends up getting us 7.642 for our first row, 16, 15, 5 for our second row, and 14, 10, and 5 for our third row. And then last thing we need to do is take this matrix right here, multiply it by matrix D. So we'll do that up here, I minus A inverse times D. And when we do that, we should get 58, 145, and 120. Okay, last example. This one goes through, gives us two goods, and it gives us a table. That's kind of nice. But then says find the associated technology matrix and determine whether the inverse of I minus A has all positive entries. Okay, that's something that you will go through and you should start to notice is your A matrix, okay, your technology matrix should be all positives. When you do I minus A, you can run into some negatives because we have 0 minus some of those values. But when you go through to take the inverse of that, all of those rows and columns should be positive. Okay, if they aren't, then we run into the issue of we're creating an amount of goods, but in the negative. Okay, so I can't create something, but create it negatively. Okay, so we go through and check just to make sure that these get us positive values. So we've got silicone and zinc. So silicone we'll say is number 1, zinc is number 2. And the table below gives us the required goods. So in order to produce a unit of silicone, it uses up 0.6 units of silicone and 0.5 units of zinc. And then same thing over here. So what it's asking is to find the associated technology matrix. Okay, so we'll look at A. And we've got silicone and zinc for both of those. Nice thing about the table is it's kind of set up in our matrix anyways. So for silicone, 1 unit of that is 0.6 units of silicone, 0.5 units of zinc. And then for 1 unit of zinc, uses up 0.6 units of silicone and 0.2 units of zinc. And then if we're looking at the inverse of I minus A, and we want all of those to be positive. So if I find I minus A, that is going to be equal to 0.4, negative 0.6, negative 0.5, and 0.8. Okay to have negatives for I minus A, but when we go through to find that inverse, we end up with 40, 30, 25, and 20. Okay, so all of those end up being positive. So we can say, yay, they are all positive entries. Okay. I'm not going to have you do 6.3 homework. I'm going to have you just jump to the chapter 6 review. Okay, so rather than do both, we're not going to do a quiz on 6.3. So we will just work on the chapter 6 review, which is on the front of your notes. Work day for the rest of today, tomorrow, Tuesday, Wednesday, Thursday, and test on Friday. Okay, you won't be here Monday, so doesn't mean that you can't work on your homework though, right? Yeah. And we'll go over quizzes probably tomorrow or Tuesday, so you guys can see what you got on those.